Hi everyone, and welcome to the MAT 211 review on extreme values. My name is Julia and I work for the tutoring centers at ASU. So for our problem, we have this function z, or f of xy, equals 2x squared plus 4xy minus y squared plus 20. And we want to find any extreme values that are over the region -10 to 80 for our x, and 0 to 30 for our y. So in order to find all of our extreme values, we need to find our critical points. We need to find our corner points of our region. And we need to find the boundary points. And the boundary points are where our function lies at the edges of this region. So let's start by finding our critical points. To do this, we're going to take our function f of xy, and we're going to find the two first partial derivatives, f of x and f of y. So let's go through and look at our function. This should be old hat by now, but we'll do it once just in case. So we've got, for this one, we've got, for the first term, we've got 4x, so that's for our f of x, plus 4y. And then these two terms, neither of them has x in it, so they're just both going to go to 0. And for our f of y, we're going to have 4x from this term. This term will go away. And then minus 2y. So, in order to find our critical points from these, we need to set both of these equal to 0. So we'll be solving a system. 4x plus 4y equals 0, and 4x minus 2y equals 0. So we can just go ahead and use subtraction for this, since we've already got 4x and 4x in both of our equations. So that's nice and easy for us. So we'll just go ahead and we'll subtract these. So we'll have 0, and then we have 4y minus negative 2y, so that's positive 6 equals 0. So this says that we have 6y equals 0, and if we divide out that 6, that just gives us y equals 0. Then we can take our y value and we can substitute it back into one of these two functions to find the corresponding x. And so let's go ahead and use our second. So we have 4x minus 2 times 0 for our y equals 0. So that's just 4x equals 0, and therefore x also equals 0. So this means that we have a critical point at 0, 0. Great. So now we can move on to finding the corner points of our region. We'll do this by looking at a quick graph of our region. So we have x and y here, x and y. We know that we have -10x, so we have a line here. So we can think of that as x equals -10 for the outer portion of it. So that's the minimum x value that we could have. And we have 80x up here. So we'll say this is 10 or -10. And this is 80 for this guy. So that corresponds to 80, right? And then we have along our y values, we're going from y equals 0 to y equals 30. This is probably horribly off scale, but you get the idea. So we have a corner point at this point, this point, this point, and this point. So let's look, since these are all straight line functions, let's look at what they are. So at this point, we know that x is -10 for this green point on the top here on left. And we know that our y is 30. So let's write that a little nicer. That's totally smushed in there. Get out of here. And we erased our spot too. That's okay. Put him back in there. And we'll rewrite this. So we've got -10 and 30 for this point. For this point down here, we've got -10 and 0 because we're running along the 0 line here. For this point, we've got 80 and 0. And for this point, we have, well, x equals 80 and y equals 30. So those are our 4 corner points. Let's go ahead and write those over here. So we've got -10 and 30. We've got, I'm going to run out of room here. So let's erase this a little bit. Got -10 and 0. Got 80 and 30. And we have 80 and 0. Oops. 80 and 0. Definitely don't want to make that mistake. Okay. So now that we have all of our corner points, we want to find the boundary points. And so those are the points where our function intersects with the boundaries of our region. We could potentially find an extreme value along these boundaries as well. So to find the boundary points, we're going to plug each boundary line equation for f into f of x, or f of xy here, and we're going to take its derivative, and then we're going to set that derivative equal to 0 and solve. So let's see how this works. So first, let's write in our other 2 boundaries because we forgot to do that. And we have y is 30. So those are our 4 boundary equations. So let's start with x equals -10. And we have our function. It's going to be f of -10y. So we're just going to substitute in -10s for all of our x's here. So 2 -10 squared plus 4 times -10 times y minus y squared plus 20. So if we solve that out, this will eventually look like -y squared minus 40y plus 220. And we're going to set that equal to 0. Oh, actually, no, we are going to take its derivative first, and then we are going to set it equal to 0. No, no, no. Don't skip that step. So let's take the derivative. We'll call this function, let's call this g of x. So we're going to say the derivative of g of x, or g of y, excuse me, is -2y minus 40. And then we'll set this equal to 0. So that gives us -2y equals 40. And we have y equals -20. Oh, and you know what? I see where we made the mistake here. I knew this didn't look right. This was supposed to be a, oh no, it is supposed to be a minus because there's a -10 in there. So that is correct. So that is a minus there. And minus, minus. Yep, that all looks right. Okay. All right. So now that we have this, we are going to just recall that our x was negative 10 at this point. So we have a point negative 10 and negative 20. Great. So next, we're going to look at x equals 80. We're going to do the same thing. We'll just substitute in 80 here. And we'll just erase all this, come back to that. So we've got an 80 here, got an 80 here. That gives us negative y squared plus 320y. So I'm just reversing the terms here. Plus 12,820. We're going to take the derivative of this. We'll call this again g of y. So g prime of y will be negative 2y plus 320. And we're going to set that equal to 0. So that gives us negative 2y equals negative 320. And it follows that y equals 160. However, we can stop here because we know that this boundary point would be 80 and 160, right? But this boundary point is outside of our range for y. So we are going to not use this boundary point because it's not actually inside of our equation or inside of our region. So let's get rid of this and we will move on to looking at our y equations here. So first we have y equals 0. So we're going to have x 0 here. And we'll have 2x squared plus 4 times x times 0 for our y minus 0 squared plus 20. So this gives us 2x squared plus 20. And we'll call that g of x this time. Taking the derivative of g of x gives us 4x. And we'll set this equal to 0. And that means that x is 0. So we've got the point 0, 0. Well, we already have that in our critical points. So we won't repeat it in our boundary points just because we already know that we're looking at that point. So lastly, let's look at the case where y equals 30. So I'll put a 30 in here, a 30 in here, and a 30 in here. So this gives us 2x squared plus 120x minus 880. And we'll call this g of x again, just for notational purposes. We'll say that g prime of x equals 4x plus 120 and we'll set that equal to 0. That gives us 4x equals negative 120. So x equals negative 30. But again, this is outside of our region because we only go as low as negative 10. So we won't include this point either. So all told, we have the 6 points here that we've written in here. We have 0, 0, negative 10, 30, negative 10, 0, 80, 30, 80, 0, and negative 10, negative 20. And actually, negative 20 also doesn't belong in here because it is also not in our range. So let's look at our values of z at each of these 5 remaining points. So we'll do 1 and then we'll just write out the rest of them. So we have 0, 0. That means that z equals our f of x here, which is 2, 0 squared plus 4 times 0 minus 0 squared plus 20. So that just equals 20. At negative 10 and 30, we have z equals, and we'll just go ahead and write in the values here since we don't need to keep going through this equation. So we have negative 1,880. At negative 10 and 0, we have that z is equal to 220. And at 80 and 30, we have that z is equal to 21,520. And lastly, at 80 and 0, we have that z is equal to 12,820. So we see that we have a minimum value at negative 10 and 30 and a maximum value at 80 and 30. So therefore, we have the min is at negative 10 and 30, and our max is at our point 80 and 30. And z for each of these, we already know. Great. So that is our solution. So before I go, I just want to remind you all that if you are looking for any additional tutoring or academic support services, you can go to our website at tutoring.asu.edu. You can also use the tutor search tool that you can find on our website, and you can also find it by going directly to this link here. And that will allow you to find specific tutoring services for your course. So thanks so much and have a great rest of your day.